the function is always in this top down bottom, right? Top down bottom. Then your while, there must always be a while in your main functions. No procedure can run just straight through. If let's say you do not have, you just run through everything without stopping, right? Then you're just running through the whole program and then you exit. This is the one that is causing you to exit the whole program, because main have a output of integer, and that's why this value here is integer. Anyone still having problem with the screen?
No.
No, don't have.
Okay. Now, coming back to this one. Okay. Now, there's one header that I would like to introduce to you is this one. This is the one that helps you to do formatting. Notice that I actually put this function here. This is the one that format the number of characters that you want to align or you want to pad. Because I'll be using this in my solutions for assignment 2, which I will show to you next week. Same thing for this. Because let's say you want to, when you do a float, right? Like say when you show the number of digits, you only want to show 2 decimal point or 4 decimal point. Then you need to do some form of formatting. Okay. I will send all these notes to you after the session. Okay. Now this is the important one that I want to touch on, because this is very important, especially when you talk about large software and when you want to break down a particular large applications down into very small problems. So a lot of time, the main solution, the main model of designing your application is doing it in a modular form. Because if you do not do that, if you do like what you're doing all this while, right, until at this stage, you will write a very, very, very long script, right, like what you've been doing, or everything in one file. But usually in applications, you buy commercial software or anything, right, it's all in modular form. And a lot of time, you will not be the only person writing the application, because if the software becomes so big, like say, for example, Microsoft, just the Word alone, right? There's more than 10 people doing that application. And how do we achieve a single application being done by multiple programmers? It's all through modularity. This modularity is just one model or one methodology that people use. You have other methodology, because when you talk about if you look from system integrations. Apao, welcome back. Are you here? Okay, never mind. So when you talk about, like say, system integrations, right? You design an applications with different modules, but different modules are all done by different people. But how do you integrate all of them together, right? So you have to, one person will have to talk the same language as another person, because if you notice so far, all of you have been writing different programs, writing programs to solve a same problems, right? All of you are trying to solve a same problem, but every one of you have different programming style and programming methods, correct? None of you share the same kind of a process flow, share the same kind of a design. So in order for you, so like say for Hanya, and to share pass your information to, let's say, Jonathan, then if you both of you are not talking the same language, you'll be a big problem. So that's why when you talk about module, there must be a protocol that is being implemented when you do any modular programming. So that's why we are going to talk about functions today. Okay.
Okay.
So a few more key advantages of modular programming is basically it will give you a faster to develop. So your code to market is very fast, and then it'll be easier to read and understand for any programmers that's come in, need to maybe take over your code, or maybe to help you in enhancing your code or do debugging. And also, is most importantly is when you do debugging or this this troubleshooting, right? You actually have to isolate your problems and also easier to maintain. Because at the end of the day, right, modular programming is the bottom line is what is reusability. Because when you write a particular section of code, you remember programmers are very lazy. No programmers want to write the same code for every program for every application again and again and again, then become very inefficient, right? So the only way for a programmer to be extremely efficient is to design your code such that it can be reused. Oh, okay. So you want me to stop? Okay, I
Actually, I'm
pause.
finding a way to record. I think there's a way to record, but I'm not sure how.
Oh, okay. Is that right? Wait, record. Let me see. Jia Hui is recording leh.
Oh, Jie is recording.
Yeah.
Oh, then okay lor. Then
Okay.
you can send it to Bao Guang Leo.
Okay. Okay, where was I? Okay, reusability. So bottom line for any applications or code when you do, right, it must be able to be reused. Whether is it within your own circle of applications or your own domain, or it can be reused by other parties. That's why you notice that you look at, like, say, there's some kind of conventions like being done by Linux, Linux community, like the whole Linux distribution, one particular distribution, let's say Ubuntu or Red Hat or Fedora, they are done by many, many different programmers. So how do all these different programmers with all these different programming style have to adhere to a particular standard? So at a very basic, it has to be modular. Okay. I will also show you how to use this kind of a modular style in the solutions when I show you next in the session 3 to solve the assignment 2's problems. So by reusing that in multiple sessions, right, you actually cut down a lot of your these lines of code and functionality. So if, let's say, there's a function that's a problem, you can immediately identify, you solve that problem, you solve a lot of errors. So basic thing of writing a function is this is like this is a name, function name. What is so this is function name, and this is the inputs. So when you talk about adding a particular function, there's two aspects you need to remember that you need to define for every single function. First is the specifications. Second is the implementation. Now, what is specification? Specification means that you have to let your program know that in a header file, whether is it in a header file or in the main program, you need to ensure that it is being declared. Just like I told you, you need to declare and initialize. Same for when you do a functions. You need to declare, do a function prototypes. The name for declaring is called function prototypes. And then the other one is called function definitions. This is where actually you write down the information. Okay. So function prototype, usually if you look at like a lot of mainstream programs, they're all being detailed out in the header files. Then you will look more cleaner. If let's say you put everything in your this .cpp, is very can be quite messy. So a lot of time it's always good to have a practice that all your prototype all declare in your header file, because that will be included in your main application when you compile. So if you don't see it, it doesn't matter as long as it's in your header file. Secondly is the function definitions. This is where you implement the actual functions in your code. They can be in a separate portion, but I can show you that one in session 3 because there's a different kind of implementations. Right now, we just focus on getting the functions and the understanding clear first, so that you can have very strong foundations when you do your application. Okay. Any questions on this? so far?
No question for me.
Yeah, okay.
Okay. Now, this one is the key thing I need to spend a bit of time. So when you have a particular function, this one is already is in the implementation stage. You're already implementing, right? So when you create a function, so you need to have this argument. These arguments are actually all your input, meaning that what is going to be passed, what information or data info will be passing into your this function called security check. And then this information will be used in your code here, whatever, how is it being processed? And then this return type, meaning that this is the output. So the caller, okay, the caller who is passing the information to these functions, the caller that is passing this data over to this function through here, they'll be processed. Whatever result that is being processed, right, will be going out based on the type that you declare here. So when you do a return, means that this output will go back to the caller. Okay? You go back to the caller here. So the caller is expecting a return result. Clear on this one? So when you do your function prototype, when you declare, this is the implementation stage, right? So how do you declare? You will do this, you do bool, right? Security check. And then your in and in. I'll show you a bit more later when we go into it. I'll show you an actual code. So this is how you're going to be. So this is your function prototype. And then this is your implementation state. Okay. Notice that you see down here, you only just need to declare the type. You don't have to give like any variable name or anything. It's not necessary. Same thing for the output. You need to just declare the type, and then you give the function name. Then when you reach to the implementation stage, you need to give this is called argument name. This is argument. So you can give any name you want, okay? Because this will be actually declared locally, and it will be used within your function. Okay, try not to, you can do a global declaration. Global declaration means it's outside your main. This is called, anything that's declared here is called global. Anything declared within your function is called private or local or private. Okay, so you'll be able to use these two arguments, in your code, and then this makes sure that when you put a name like what I do here is result, this must also be declared inside here, your local. So it might return result is like boolean, right? So it's bool. Inside here, let me just so inside here you must make sure you have you put in your bool space result. Okay, no S space result. So you declare this locally so you can actually use to return that result to the caller. Okay. So this is prototyping. This is your implementation state, then how do you use them? You basically use this in your main. You call this inside your main. Okay. Let me just go to the next one. So once you have declared, this is how you implement this. Yeah. Let me just. Okay. You will declare this over here. And since your security check is Boolean, right? Meaning to say, what is Boolean? What kind of information can I say from a Boolean? Anyone?
True or false?
Okay, correct. So you only get true or false. So this is an expression. So in an if, right? This one is an expression, correct? So if is always looking for true or false. If expression is always looking for true or false, correct? So if the expression for if is looking for true or false, and the return result is a Boolean, which is also a true or false, I can basically use this here. I'll just plug this whole function here. Can you see that? Can you see that? So this whole thing is the function here, which I'm calling. Because since the return result is either true or false, I just plug this function here will be more than sufficient. Then the usual thing is, if let's say this is true, you do this. If it's false, you do this. Okay? Any question for this one, the function? Passing of values?
Can I actually have a question? So
Yeah.
the thing is, I understand that we are supposed to do the implementation, but if let's say if you do not declare the prototype, is it good or is it bad?
Generally, okay, depending on your compiler, your IDE, sometimes IDE they can detect and then they will just help you to declare. But it's always a good practice to implement your own prototyping, because when you use different kind of compiler or different kind of IDE environment, right, you always need to declare. And for your own, let's say you're the only programmer, it doesn't matter. But let's say you are working with a team of programmers, usually they will need to know what are the different prototypes that you have at your site, because maybe they include that in their header files, but they did not include your functions. And in order to optimize, maybe they don't even need to include your functions in their particular code where you already have them in your headers. You see my point? So a lot of time, the function prototype is there to declare, to specify which are the different functions, or so-called, it will lead to something what we call API. If you notice API, they are actually calling different functions that you can actually bring return back whoever called that particular items. We'll address more about API later, because API has a lot of attributes. That one must can discuss in more detail. But a proper declaration is always good. Simple application, it doesn't matter. But
Okay, understood.
Long term, if let's say you write a very large application, yes, is in fact it's good that you must put your function prototype. Okay.
Okay, thank you.
Anyone else got questions? So if you notice, if let's say I do something like this, right? This one, this particular implementation, I can reuse this again somewhere down the line. Right now, I can see. Right now, if let's say the person, this is false, unauthorized. Maybe unauthorized, I go and do something like change the level of the employee, actually the level of the person, and I can do another check again, one more check. So it's like if, and this whole thing again, then I do something else. This is what we call reusability. To reuse you write this function one time, you reuse here 1 and 2 times, or many times, depending on how your code is being implemented. Okay. So function is a very important tool that you need to ensure that you understand. And I think I saw one of you is that you use a lot of functions. You already have functions in your code, but you don't have any of this, meaning that you don't pass information. If you don't pass information, then it's not really called functions. It's called subroutine. Okay, subroutine basically is you do this like a flowchart, right? You do this, and then you do a jump, and then you jump to something else. You do something here, then you jump back. Then you jump here. Then this one is actually your subroutine. This one is actually your subroutine. But function is not like that, because subroutine cannot be reused. Whatever that you do here is really is a similar of a procedure that you're supposed to be doing here. But rather, a function is something that if you were to put this become a black box, not only this particular main code can use, maybe your some other friends or colleagues, they can actually use these functions in their code as well. Okay, so make sure that it's a different thing. Functions and subroutine, they are not the same. Okay, they're not the same. Okay. Next, I'm going to touch on something we call reference. Let me see. Okay. Referencing is something just like I showed you just now in the functions, right? You pass that data to another. You pass your data. The caller will pass the data over to the function, but a lot of time is basically passing the data, the value. Let me just go back here again. So you see, what we are doing right now is that when we do this, okay, this, you're basically passing the value of your current level, current staff level, for example, and then passing the current value, the value of the employee grades. So when you pass the level, this information, right, to these functions, if, for example, I were to do this, set level equals to, because I'm passing this over to this function, right? If I were to change, let's say, for example, the value here is 5. Okay, pass value of 5, level 5, right? But if over here in the function I change to 10, will the current level change to 10? Anyone?
No.
Yeah, I would say no. Why? Why no?
No, the security level is increased lah, so will increase, but the current level have to check whether they will pass or authorize or not authorize.
Not exactly, because you see, when we do this, okay, before that, you understand that okay, this one is called current level, right? And this one is called security level. But this and this, they are exactly the same. Yeah, good point that you highlight. I think I did not explain on this part. When you use this current level is being declared here. You see here? In your main program. So the current level is actually a a variable that is declared in your main program, and then it's being used somewhere here, right? Maybe within the program here, current level was being given a value of 5, okay? And then you pass that current level into your security check. So what happened is that this sec level will have a value of, if the current level being passed is 5, this one, if you do a C out of sec level, this one will show, yeah, hang on, I'm trying to pull down the value, very slow. So this one, the output will show 5, okay? But if subsequent after this, you were to say in this level, you were to change this to 10, and within this function, you do a C out again, right? This one will show 10, but this 10 does not change this current level's value, because it only changed the variable here. You understand? This one need to understand very clearly, because this one is very important when we talk about referencing. Yeah, someone put a question. Okay, Jonathan, you got it half correct. Okay, now, why half? Let me just, okay. So, okay, you are correct to say that this one over here, these are all local, correct? These are all local. So, but it does not affect the Boolean side. It doesn't affect. It has got nothing to do with that. Let's let's not focus on this one. Focus on just between this sec level and this current level. Because understanding how this information is being passed is very important when you do referencing. Because referencing will go a very long way. A lot of time when you create functions and when you do your program to be reusable, the key thing is that information sometimes need to be changed from the caller side. This is the caller. Okay. This is the caller. Okay, main right now in this particular program, the main is the caller. Because you see, I put the function here. And then this is your function here, right? So the caller, in this case, right, does not need its information to be changed at the caller has its own current level. It does not need to be changed by a functions in this security check. It just need to do some checking after passing the data. But what if, let's say, the current value wants security check to upgrade that level if the user is low? Meaning to say that it wants the security check at the same time while checking, change the level of this current level from 5 to 10. From 5 to 10. So that's where your referencing comes in. Okay. So, but first and foremost, the data being passed to here, you understand? This one need to be clear first. I can go through and explain again, okay? So you notice this is within main, okay? This is within main. So this thing within main. So this current level is declared here, right? This is declared here, right? I'm declaring here. And then I will put a value here. Okay. So current level within main right now is level 5. And now I'm passing this level 5 to security check. Okay, so calling this security check means that I will invoke this particular function here, correct? So when I do that, so this sec level becomes number 5. Then when they do anything within here, they will just do the check if, let's say, sec level more than, let's say more than 4, then you'll do something. After that, they send the result. Okay. So this particular function at this moment in time, do not change the value. Do not change the value. And if they were to change any value for the sec level, it's only happening within this function here. Okay. So these are all done locally. So okay, locally, maybe easier to explain. These are all done locally. So what if, for example, that you want this security check to change, you want this security check function to change this current level data, the value. Then you need to do some things like, let's say you want to change, you send 5, and then I want to change the current value from this, I want to change the sec, not just sec, sorry. I want to change maybe a different color. So I want to change the, right now sec file is level 4. I want to change the current level, which is from the caller. I want to change the value to 10. So how do we do that? So that's why referencing comes in. It will help you to be able to change that current level that is from here, that is here in this particular function here. Okay, you all got an idea? If not so clear, never mind. When I touch on referencing, I'll need you all to try some code. Then you can see why is it like that. Okay, so just a bit of theory. So when you talk about referencing, you're basically to operate on an existing variable memory addressed inside the C program. Okay, you're basically trying to touch on a particular variable in the memory system, in your program's memory. You're going to do some assigning and then sending and returning of the data. Okay, but you're not basically changing the value, but you're actually calling the address of that particular variable to change the initial value. Because you see, when you do this, right, passing a 5, and then passing a 5 here, your data actually is being duplicated. In actual term, if this one uses 4 bytes, this one also use another 4 bytes. So there's a duplication, right? You're taking out memory, right? But if you were to do addressing, you're actually not using, if the value is very big, let's say a float, you're basically using the size of the address only. That's why I said it's using memory. So the way to call a reference is using this particular operator here, ampersand. Okay. Okay. I need you all to write this code. Start coding now, and then you look at this, what I'm doing here, then I'll explain. I give you all 10 minutes. Okay, all of you have done already this one. It's just a very short code. So this one gives you some idea on how actually is to, okay, good. Is how to actually, what does this particular referencing mean? Because when you change, let's say when you change a actual, right? Just by changing this, you change the original caller. Because you're passing, this guy is passing the address of this over to the other int. That is the reason why when you change other int, your actual also change. Okay, good. Now, let's do the next one. Now, this one, please key in this one. This one will give you a better understanding of how to include the uses of this function. Also function prototypes, and then calling the functions. Okay, I want you to key in this one, the remaining section of here. So this one will help you understand, including the use of functions, passing the variables, passing the reference. Okay, then you can see the values here. This will give a better picture. Let me just clear the screen to be easier for you. Okay. Now do this code. We'll come back in 3:10. Give you some music. Okay, answer Jonathan's question. Now, if let's say you don't pass reference in the function input, so what you're passing basically is the value of the variable in your main. Okay, so meaning that the mains input, which is the mains variable, in this case, let's say actual length, that initial variable that is being assigned to the actual length in the main will not be changed. So the function has got no authority to change the caller's variable in the main function. Did I answer your question?
Yes. So when you put the referencing, it has the power to
Correct.
change back the mains input the variable that you set over there. Okay,
Exactly.
I understand.
So when you pass that reference, you're giving authority to whoever the functions you're going to call. So they have the right to change your initial value up to whatever that they deem necessary in their own function. Okay. So that's why referencing is very powerful. When you give when your initial values, right, it's not this, you're giving authority or the power for other functions to change your initial values or your subsequent processing of that particular variable. A lot of time in any commercial application, right, that is required because the main cannot do everything. So when you do delegations, let's say we do all different modules, modular design, right? So different functions require the authority to change the initial value that was being assigned at main, because once main delegate all the works and the tasks to all the different functions, all the functions supposed to work autonomously by right, because you're calling them as something like a black box, right? So by calling them a black box, they should have the autonomy to do whatever values that you pass the information for them to do. So that makes your individual functions become very powerful.
Okay, I understand. Thank you.
Okay, the add and print. So you notice that you basically pass the input variable and then you are adding, right? So when you're adding, the initial caller variable was not changed. You see that you actually print, you see, I actually include the, let me see, whichever you're mentioning, you're referring to this, right? So, yeah. So I'm calling these functions over here, okay? So basically is this actual int is being passed over to input variable here. So this input variable just add additional one. If let's say this input variable is like say, I think it's 102, and then input variable becomes 103, but your actual int is still 102 when you print this one out here. All right. This is to show you that even though you pass the information and you add one in your functions here, the initial value actual in here did not change. Okay, when you guys finish, you want to take a break for a while? You mean this one? You mean here? This past reference.
Yeah.
Okay. You see, initially this other int is a reference of actual int. So when you pass this guy to this function here, reference function, you are actually passing the reference. Notice that the integer here, I mean the argument here is declared as a reference, meaning that it's expecting to receive a reference from the caller. Print out whatever actual value was initially in actual int, it'll be printed out here. So that what you're doing now here is you're actually adding the initial value of you're adding the caller's value, which is the actual int, address of actual int plus 1. So that's why when you see when you perform this particular function here, and then you print this actual int is actually incremented by passing the address and incrementing that value here in the external function here. So this is actually affecting your this caller's variable actual int. Whereas in this particular function, it did not make any changes to actual int. You understand? Notice this and this, they are the same, right? Notice this and this, they are the same. The function, they're basically the same. The only difference is, and calling this other int, which is declared as reference of actual int. Let me explain another way is, let me see. Okay, maybe I explain this way. And this is address. Value. Okay. Sure. This one is the name. So show in. So actual int, the address, let's say, is 0001. Okay. So your initial value for actual int is 100, right? So the value here is 100. Now, when you do this other int, the name, other int, at the back of the system, right? Basically is what happened is, of course, other in the memory, there's you cannot copy this. This must be incremental. Let's say this is 002. But when you do referencing, this actually holds the data of, let me use a different color. This actually holds the address of 0001. That's why when you pass that's why passing when you want to use other in, you must make sure that the type includes this from a reference. If not, you'll be changing the actual address. You'll be changing this address number instead of the value of this address, which is here. You understand? Okay, good. Oh, no problem. Okay, have you all done already? All of you?
Yes.
Okay. Okay, let me just move on. So basically for session 2, this is the last topic that I wanted to address because this is very important, this and the function. So by doing that, it will actually help in your this assignment 2. So knowing this, referencing and these functions, right? So can you think of how you are able to utilize these features in your assignment 2? Because that will really help in that. For those of you already submitted, if you want to change or update, just go ahead. So then the next session on Tuesday, when I show you my code, I'll explain to you all the different functions. Some of the functions I even reuse in an embedded form, means function within functions. It can be done also, which will be very helpful also. So just information, that information for you. If let's say you want to do some printf is another feature, and so far we've been using this cout, right? Cout is an object way of printing out. It's an object way of doing all this function. This one function printf. Other thing other than Jimmy using using printf in all his codes. But printf it can be more detailed and defined because you're doing basically f is the formatting. You can do whatever formatting you want, right? Down here. So you're passing that, just like here, you're passing the reference of actual in over into, yeah. Same for this, you're passing the address, the referencing or the address over to this particular x here. And x is showing the value of the other int. Okay, this is another way of displaying your this information. Okay. Okay, just to recap, so far we already covered all these chapters, with the exception of this data structure. This data structure, I will touch on this in session 3, because in order for me to touch in more detail for this one, we need to learn some array functions and all your this initial chapter 1 to chapter 5. Okay, so by utilizing all that we have learned so far, we will be looking at data structure and how to build a database using data structure alone. Then after that, we will link that to other applications. Okay. So far, any questions from number 1 to number 7? Any questions?
I think we should be good.
Okay, good. Now, okay, no problem. As long as you got any questions in your code, just let me know. I will look into your different, what are the areas that you might be, or your maybe the difficulty, let me know. Then I can maybe give you some ideas or some hints on how you can actually enhance in your own code. Number 4. Jiahui, you only number 4 here. This one, I thought you already have while, do while, and for, right? Okay. So your array, have you done your array already so far? Okay. Jiahui, what I'm going to do is you just stick to this one-dimension array first. So next week, when I go to session 3, I will go through my code and I'll touch on this two-dimensional. So that from my code, when I explain this particular multi-dimension, right, for the assignment 2, probably it'll be much clearer. I'll go very slow. So maybe for session 3, I'll spend maybe 2 hours just on the assignment 2 and to explain to you through my code. And my code don't use advanced tools like say vectors or multi-dimensional array, just 2-dimensional array, one type. And then you'll be more than sufficient to just cover the assignment 2. I'll explain to you in more detail. I mean to all of you next Tuesday. Okay? So just try your best, finish your assignment 2, even though you got use just one dimensional array is fine. But even if you don't use a one-dimensional array, also fine. Just lower points only. Okay? But still must submit by next Monday, 2359. Okay, I'm going to touch on some a new term. It's called rapid application development. Okay, I'm just gonna. It's a bit more theory and information, so you just hear me out for a while. Okay. Now, traditionally, when you write any applications, right? So there's this thing what we call the SDLC. Just use a different color. So SDLC basically is term for what we call the software development life cycle. Traditionally, we would do things like what we call waterfall. Waterfall is a methodology long time ago, and even up to now, those enterprise software will still use this waterfall methodology. Waterfall is actually a process where you have an objective. You must know, firstly, what is the objective of the software, of the requirements, objective and requirements. And then, secondly, you need to know what is the final outcome. So a lot of time, software houses, right, when they look at the different problems of their customers, they will need to understand in very detail of the objective or what they're trying to achieve and the current requirements that they have. And ultimately, they need to know what the customers would like the software or the solutions to be. So that's the final outcome. So by doing that, that's whole software whole life cycle, the requirements will fall down back to your design, will fall back down to your prototyping, then your different modular functions and everything, then testing and so forth. Okay, so that's why it's called a waterfall. But you notice that when you do this, right, even though they have a cycle, you still can implement a certain amount of agile, but it is still in one directional process. Meaning to say, a lot of time when this design is being done up, they don't go back here and make any changes. They just flow that back to prototyping. Then flow that back down to different different module by different people. Like I told you about the modular design. All these are being done up, are being distributed to different people. And once they're done, a project manager will basically oversee this whole process and then go through the whole timeline and then do testing. Testing, you have internal tests, end user tests, and then acceptance tests, all these things, before it's being rolled back out to the customer. So this has been doing very well all this time. But the biggest drawback for this is what? Can anyone guess? What is the biggest drawback? Time, okay, close, but in more detail or more precise, what is actual problems in this waterfall? They have a very big problem. Manpower can be planned because if let's say you know what's the requirements and objective, a seasoned program manager will know what is the different resources that's needed. Then they can plan out what are the manpower that will be needed for this whole process. So manpower not really a problem. Okay, one directional, yeah, but why is it one directional? In what sense? Okay, Guang is right. Correct. And you're also correct. You see, when you do a waterfall, right, it means that the requirements that's been given either by the customer or the consultants or wherever they require it cannot change, it's fixed. Any change in the requirements that will require all the process all to be changed or to be cancelled. So that, and a lot of time requirements have to be ironed out, put into contract, and then to run the whole process. But what happened is, if customer suddenly during halfway through this process, customer say, oh, there's a change. I need to make a big change on this design because of some requirements by their own customers or by their own process. That's where waterfall become a very disadvantage. Okay. Yeah, that's right. Correct. So that's why in the current age, right, you will introduce things like, you introduce a new methodology that is being used, very popular in the market right now, is called Agile. So Agile is something similar to waterfall because software development life cycles still exist. You still must have. But what happened is you go through a multiple cycles. Let's say requirements and objective, and then you go through let's say a draft design. So these requirements and the draft design will go back and forth in one particular cycle. Because a lot of times you tend to hear things like customer do not know what they really want. Let's say, you just look at the design of, like, say, Apple, right? When Apple did not come out the iPod, nobody knows that people actually was looking for an iPod and in this kind of fashion and designs, until the manufacturer of Apple or some other companies that come out, like Sony, come out a particular new product. Only then do they know that actually end user, the consumer require that kind of a device, that kind of requirements. So which means to say, by depending purely on requirement alone, might not be a best, will not give you the best outcome. That's the reason why currently in the current technology, people don't tend to use waterfall anymore. Everybody is moving on to this agile. Now, so back to doing agile, requirements will constantly go through a draft design by the design team to see whether is that kind of requirements, that kind of a style, that kind of a process, or that kind of an outcome by maybe doing some prototyping. When I say prototype, it doesn't mean to actually design something. You can use piece of papers, you can use multiple, cardboards, just to simulate to the end user that this is the kind of a response that you'll be getting. Is that what they want? So constant cycle between the draft design and the requirements will happen before it goes back down to design and prototyping. Would that be another cycle? even this cycle, they have a different levels. Even you can do design, prototyping a few cycles within, you can go back up again. Okay. So this enables customers or consumers who do not really know what kind of outcome they're looking for. Okay, what kind of outcome they're looking for. When they see some form of some aspect of the final outcome of a product, then that will give them more confidence in the kind of requirements that they want. So that's the reason why Agile will help to minimize, delays in changes. You are basically isolating the different process because it's down here. Down here, maybe you need the higher management, for example. Higher management to be involved here. But over here, you probably need the senior engineers or marketing, for example, to be involved, where you don't need a senior management. So you don't really need a very high resources in terms of the companies on the company or even the consumer side to be involved in this whole process. So that will cut down manpower. Or in short, is the allocation of manpower. So and so forth. So by doing that, basically what you'll be achieving a lot of so by doing that, you actually cut short the whole design life cycle. Because if you look at this whole process, right, by the time you reach the stage of doing the production process, right, that production revision, right, it might be, like, say, one or two, but this one or two revisions in the production side has already gone through multiple revisions here. The requirements have gone through multiple revisions here and multiple revisions here. So by the time you reach the production cycle, right, the requirement is actually very clean cut, right? It has already, in a way, filtered out unknowns. You're basically minimizing all the unknowns in your requirements before you come your production. So that's the reason why when you go through this agile, another thing, the advantage is your software quality will be much higher than a waterfall process. So if the quality is much higher, what does it mean? It means that your testing process will not be as intensive testing and debugging. Will not be as intensive as waterfall. Correct? So that's why Agile right now is a key in all the implementation of software development. So no one is going back to waterfall unless it's like a traditional enterprise, with a lot of what do you call that? Historical processes that they cannot change immediately. Huh? Restaurant means what? You're talking about the company, huh? So our company must adopt Agile. If the mindset don't change, this is really a mindset thing, right? Mindset thing, right? If your mindset don't change, there's no point. But that's why the mindset must change. Okay, so this part basically I understand, right? Before I touch on rapid development, RAD. So now when we talk about the Agile, back to Agile again. So RAD is an integral part of this agile software. In order for you to be able to run through rapidly within that cycle, so you have many cycles, right? Many cycles running within. So rapid application development, in our case, it's just software. We talk about software part. But processes, logistics, productions, manufacturings, they have their own way of doing rapid application or rapid development. But that's a different story or different domain. So our focus right on in here is basically what are the different tools. When I say tools, doesn't mean software tools. It might mean your methods, your processes. What are different tools that will help you to do rapid application development? Okay, so that's why cutting short the development time cycle, development time is very expensive. You must constantly minimize that cost. And to do that, you can only do things with RAD, rapid development. So a lot of time, prototyping, testing. That's why you see when I talk about, just now I talk about functions, right? Modular programming. So let's say an app will have different modules. So that's why this one is, let's say, for example, this one is your main will call, let's say you will check stock. Then you will check stock. You will have this own, let's say, decision mechanism. And then you will do, let's say, update. So a lot of time when you do, let's say you do this particular, let's say, for example, you are focusing on doing this, focusing on this particular module. So when you do stock check this particular module, right, you can do its own internal check. Let's say this function, I know you cannot do void. Okay, yeah. So let's say you do like integer check stock, and then integer ID. So within your function, you can do a lot of, let's say, debugging, internal debugging. Debugging means what? You can actually check whether the values here, input ID, if input ID is it, if more than, let's say, a particular character, let's say 10000017. So you can display them out. Internal checking, internal verification. Let's say you want to confine or restrain a particular input. You can do all your validation inside here. Validation and verification. Do all within here. The bottom line is to turn this function, this particular module, right, into a black box. Meaning that you can throw any value inside here, it will not crash your system. So in order to, if that's the objective, right, what do you need to do in these functions such that whatever output back to this decision making, right, you will not crash the whole system. So that leaves your development cycle within this particular function here. So it puts a focus. Let's say this one done by programmer 1, this one done by programmer 2. In session 3, right, next week, I'll be implementing something like this. for your assignment, meaning that one of you will do this particular function here, another person do this, or maybe two or three, maybe two-person do this, two-person do this, and then another two-person do this. Okay? It'll be very interesting. So by doing that, all of you need to communicate. How are you going to pass the information among each other? Because the information that is being passed from here to here must have the same practice and protocol between passing information from here to here, right? Correct? If not, then everyone has its own communication. Then your data, when it goes one cycle, will be a big problem already. Any question on this? Yeah. So at least you have a taste of what working in the software house is. Because when you work in a software house, there's no one silo developer. Everyone is dependent on each other. So how do we do that? Then we will work on a particular problem next Wednesday. I mean next week, next Tuesday. Yeah, and in a common language. Huh? What is div2?
Sorry, Nelson, just ignore, just ignore.
No headache. Important thing is understand this whole, what I'm explaining here is the methodology. Because this one you need to understand this concept, because next week when we touch on session 3, it'll be a totally different ball game, because I'll be touching on the data structure. Okay, from data structure, gradually I'll touch on database, and then when you work on the mobile app, it'll be much simpler. Because mobile app, your application is supposed to access something external outside your current domain. Because when you know how to do that, right, you'll be able to implement what PlayStation 2 or 4 or PlayStation 4. Okay, when you implement all these that you have learned into your mobile app, you practically can create an interface to work with any hardware. As long as you can do communication, whether it's Wi-Fi, Bluetooth. You want to play game, is it? Take a break first.
Guys, let Ken finish.
So I'm basically about there already. So today's session basically is to cover whatever that we have lost or we couldn't complete last Friday. And this is what I need to cover. So before I end, any questions for your session assignment 2 after knowing all this process, especially your references and functions and the functions? Anything you want me to go through again to achieve this one? Just don't think too complicated. Use whatever that we have you have learned in the last few sessions. You can accomplish these questions. You can enough for you to accomplish assignment 2. Maybe a bit of things like conversions that you need to do some Googling. But other than that, just utilize whatever they have learned in these few sessions. You should be able to accomplish session 2. You don't have to think too far like doing mapping heavy dose of vectors. No need, man. No need. It's good to do, but it's a bit overkill. Okay, good. I think I'm basically there as well. If you've got no question for assignment 2, then I think I'm done now, so far. We can clock out at 4 o'clock. Can 5 o'clock is no problem. 5 o'clock means that from now till 5 is Q&A. If let's say you have any question, you can always ask me. It's really meant for you to go through. Most importantly is you are able to complete your assignment 2. Huh? You have not started yet. You have to start. If let's say you're not going to, if you're going to use just one-dimensional array, you can complete no problem within a day. But you have to start now. Yeah, you try to draft out, Jia Hui, try to draft out. Remember I mentioned about pseudo coding? Means that your initial flow, or even the case where, you know, the flow chart diagram, at least do up a flow. How are you going to, I mean, the flow, the logical flow of your diagram? Because remember, I mentioned the whole purpose of this, the learning outcome of these sessions or these 3 sessions is a logical thinking. The syntax side you can Google, that one is not really the key, but the main important thing is the logical thinking aspect, because that will help you to bring over when you bring over to session 3. Because if you go to session 3 without understanding about dimensional array, and on top of that without logical, then it's very hard for you to do up any applications after that. Okay, good. I'm open. Any question, just ask me until 5 o'clock. Okay, thank you, everyone. I will shut down this one. I will take out and share the screen already.